if the object was accelerating, what if this same question was there and they said it is accelerating downward or they can say accelerating downward or they can also say decelerating upward. If they use the term, it is decelerate upward. So that's the same thing. Decelerating upward means acceleration is downward, means the downward force is greater than the upward. So in that case, we'll write D plus mg, the upward force, downward force minus the upward force is equals to ma. And we'll simplify in that case. So D plus mg minus T is equals to ma. And these two will move other side and we'll get the value for D. So if it is accelerating up, upward force is more. If it is accelerating down, the downward force is greater. So in that case, the downward force minus the upward force will be equals to ma. So our topic of today is about the center of gravity and center of the mass, then about the density and the upthrust. The center of the gravity and the center of the mass. You have studied this before, the concept of the center of the mass and center of the gravity. But in IGCSE, you consider the center of the mass and the center of the gravity are the same terms. When you studied that point, you consider both of them are the same terms. But actually, there is a difference between the center of the mass and the center of gravity. How the center of the mass and center of gravity are different from each other. The center of the mass is actually a point around which the mass is evenly distributed. So, if I have an object, I'm representing in terms of particles. So here is an object, and this is and the particles are around the object. So what is the meaning of the term center of the mass? The center of mass is actually a point around which the mass is evenly distributed. The particles are evenly distributed. Example, here 3 particles on the left and 3 particles on the right. 3 particles up, 3 particles down. 4 particles here and 4 particles here. So what actually happened, there's a specific point around which the particles are evenly distributed. What we call that point, we call that as a center of the mass. So center of the mass is actually a point around which there is an even distribution of the particles. Like the particles are evenly distributed. Is it clear? The idea of the center of the mass? So center of the mass is simply a point around which there is an even distribution of the particles. And it's not like the center of the mass should always be at the center. It depends on the distribution of the particles. Like if we have an object and we have more particles on the left hand side and we have few particles on the right hand side. What is the likely position of the center of the mass? A, B, C. What is the likely position of the center of the mass for this object? Is it A, B, or C? You can use the chat to answer. The likely position of the center of mass, A, B, or C? The correct answer for this one is A. Because, as I mentioned, the point around which the mass is evenly distributed. So, at this side, we have more particles and on the right hand side, less particles. So what will happen? The center of the mass shifted more toward this side so that the number of the particles on the right balances with the number of the particles on the left. If B was the right answer, like if we select B, so with reference to B, on the right hand side there are few particles and on the left hand side there are more particles. So it means the mass or the particles are not evenly distributed. But for A, around A, the particle are evenly distributed. Like example, if 10 particles on the right, there will be 10 particles on the left. Because on the right hand side, the spacing between the particles is large. So we need greater length to cover the same number of the particle. But on the left hand side, the particles are closely packed together. So we need a small space to have those same number of the particles. So the center of the mass can shift depending on the distribution of the particles. But if we use the term uniform, when we use the term uniform, it means the center of the mass is exactly at the center. So uniform objects always have the center of the mass same at the center. Like example, if I have a meter rule or a meter scale and I say I have a uniform meter rule, so where the center of the mass will act, the center of the mass will act at the center at a 50 centimeter mark. What about the center of the gravity? If you want to find the center of the gravity, the concept of the center of gravity, it is a point where weight of an object acts. Because whenever force is acting on the object, the force is acting at a certain point or there's a point of action of the force. So we have an object is there. Say it has a mass of 2 kilograms. So 2 multiplied by 9.8, what will be the weight? It will be 19.6 newtons. Because weight is mass multiplied by gravity. So we got 19.6 Newton is a weight. So for this object, at a specific point, the weight will act. The whole object will experience a force of 19.6, but there's a specific point at which this force will act. And what we call that specific point, we call that as a center of gravity. So center of the gravity is the point where the weight is acting. And center of the mass is a point within the object where the mass is evenly distributed. So center of the mass and the center of gravity have different concepts. One is about the distribution of the mass and another one is about the force of gravity. For uniform objects, whenever we have a uniform object, the center of the gravity and the center of the mass are the same thing. But for non-uniform object, the position of the center of mass can differ from a center of gravity. Is it clear? This idea? The definition of the both, the center of the mass is a point which object mass are considered to be concentrated. Like this is a definition of center of a mass. And center of gravity is a point where the gravitational force act on the object. That's the center of gravity. So center of the gravity is different from center of the mass. How we can work out the center of the gravity from the masses, or how we can work out the coordinate of the center of the gravity? From the center, from the masses, say we have 3 different masses are attached. This is 1 kilogram. This one is 2 kilogram. And this one is also 1 kilogram. And they're all attached by a rod, which is 1 meter long. And the distance from the centers, their centers is example 1 meter. So this is 1 meter and this also 1 meter. And the question is work out the coordinates for the center of the gravity. Like we have to find the center of gravity of this system of the particles. So how to work out the center of the gravity for the system of the particle in which the particles are attached with each other. So we will make an axis, like we'll take an x-axis and the y-axis. So draw horizontal line. So this is representing the x-axis. Draw vertical line. This is representing the y-axis. So how we can work out the center of the gravity or the center of the mass? So the coordinate we want to work out, like this is a system, say 1 kilogram, 2 kilogram, and another 1 kilogram mass is there. They're attached by a rod. So this was an object. And we want to determine at which position there is a center of the gravity act. So we will work out the coordinates of the center of the gravity. How to work out the coordinate, the x coordinates? That is, we sum the mass into x divided by total mass. And if we want to work out the y coordinate, sum the mass into the y coordinate divided by m. Like first when we take, like this is example m1 for us, the first mass m1. This is m2 for us and this one is m3. Now if I want to work out the coordinate for center of the gravity, x coordinate and y coordinate, means which position it will act. So how to work out the x coordinate? If I take m1, which is 1, multiply x is a distance. So how much is the distance? So distance is also 1. So 1 multiplied by 1 plus the second mass is 2. And what is the distance from x-axis? So distance from x-axis, because it is at the origin, so the distance from x-axis is 0. Then we take the third mass, which is m3, which is 1 kilogram. And what is the distance from x-axis? How much is the distance from x-axis? 0. Because it is on the y-axis, it does not have any x-axis distance, so it is 0. Divided by the total mass of the system. What is the total mass of the system? 1, 2, and 1. So the total mass of a system is 4. So what will be the x coordinate? This will be 1 multiplied by 1 is 1. So this x will be 1 by 4. Means the center of the mass will act at the distance of 1 by 4 from the x-axis. Means 0.25. X by 4 here is representing like 0.25 meters. And what about the y coordinate? How to work out the y coordinate? So mass of the system. Our distance for M3 is 0 because we are taking the x-axis distance. When this is on the y-axis, what is the distance from x-axis? The value of x-axis. The value of x-axis is 0 for this. The x-axis is a horizontal distance. So when there's a mass, when we talk about the x-axis distance, this x-axis distance was 1. This x-axis distance was 0. And this x-axis distance is also 0. When we talk about x-axis. Then when we talk about the y coordinate for these masses, what is the distance here? 0. What is the distance here? 0. And what is the distance here? 1. The y-axis distance. And we do the same manner. We solve in the same manner. That mass multiplied by the, like mass 1 is there, multiplied by y-axis distance 0. Plus the mass 2 is there. The y-axis distance is 0. The mass 3 is there and the y-axis distance is 1. And divided by total mass 4. So it will be 1 by 4. So what does it mean? The coordinates of the center of the gravity, the x coordinate is 1 by 4 and the y coordinate is also 1 by 4. So means 1 by 4 from x and 1 by 4 from y. So where the center of the gravity of this system will lie? The center of the gravity of this system will be at this point. So when we have the system of the particles and we want to work out the center of the gravity, that's how it can be done. Is it clear? Muhammad Isa, should I repeat? So I'll repeat, I'll give another example. So when we have the system of the particles and we want to work out the center of the gravity of the system of the particle. Example, say I have two masses. One is 2 kilogram, another one is 1 kilogram. Okay. Now what I will do and say they are distance 1 meter apart. It can be any distance. Just to make it simple, I'm taking 1 meter. So first thing what we do, we draw the axis at one of the mass. So it makes the question very easy. So we draw the axis at one of the mass. Now we want to we want to determine the center of the gravity, the x and the y component of the center of gravity, where the center of gravity will lie for this object. So first, how to work out the x coordinate, the product of mass and the x values divided by total mass, and how to work out the y coordinate, the product of mass and y axis divided by total mass. So when we check for this one, like when we work out the x coordinate, the mass is 2 and the distance, because this is at the origin, so the distance of x-axis 0 plus the mass is 1 and the distance is also 1 divided by the sum of the masses 3, because 2 plus 1 makes 3. Why 0? Because this is at the origin. Like I took the axis from here, so this is acting on the origin. The value of the x and the y at the origin is always 0. So this will be 2 multiplied by 0 is 0 plus 1 divided by 3. So x coordinate will be 1 by 3. And what about the y coordinate? The y coordinate for this system, the mass is, yes, you can take 1 kilogram as a origin as well. Then it won't make difference. It won't make difference. So you can take 1 kilogram, but then you will get a negative value. But it won't make difference to the final answer. So 2 is a mass and the distance from the origin is 0 for x-axis. 1 is the mass and the distance of the x-axis is 1. So 1 multiplied by 1 is 1. So 0 plus 1 is 1 by 3. So the x coordinate is 1 by 3. Now what about the y coordinate? Look, they both have the y-axis distance 0 because they are on x-axis. So the mass is example 2, the distance from y-axis 0 plus the mass is 1 and the distance from y-axis 0 divided by the sum of the masses of the system, which is 3. So 0 plus 0 divided by 3. So this will give us 0. So means what are the coordinates of the center of the gravity? It is 1 by 3 and 0. So where 1 by 3 and 0 will lie? Like if this total is 1, the length of total is 1. So 1 by 3 will be somewhat here. So and 0. So this will be 1 by 3 and 0. So where the center of the gravity will lie? Like this system will have the center of gravity at up this point. Is it clear? How we work out the center of gravity of system of particles? Anyone having a doubt or a question till this point?